But what I want to talk to you about is remembering the history of spillover erosion of Grand Canyon. And there's quite a story to be told about spillover erosion of Grand Canyon. And just telling the story is very interesting. And there are three authors of this paper: myself, Stephen Austin, my co-authors, Edmund Holroyd, an atmospheric physicist working with and retired from service with the Bureau of Reclamation. He was working in cloud physics and dynamics, how snow crystals form, and he worked on the Colorado Plateau with mapping systems that aircraft could use to fly the terrain. And so he had access to a large quantity of the geographic data systems the U.S. government had available. He did that in the 1980s. That's when his work was done. And David R. McQueen, he's an economic geologist with an MS from University of Michigan, also a bachelor's degree from Tennessee, and an educational science degree. And David McQueen worked with me for 5 years, and we did field work together in Grand Canyon, and we taught graduate school classes in Grand Canyon. What a place to teach geology, the Grand Canyon. Isn't that something? And so the three of us, we started doing Zoom calls, remembering the story as we, all three of us, saw it develop. And we came up with this, 50-year specialized theory for erosion of Grand Canyon. And I think you'll see that it's a relevant discussion, not just from a history point of view, but it adds tremendous meaning to the present. Now, let me begin with superlatives. You know what a superlative is? It's something that's to an extreme, or the best, or the top. And so let's talk about Grand Canyon, of course, and let's talk about some of these superlatives. I've got three superlatives that will really direct our attention. Grand Canyon is the best known example of hydraulic erosion on planet Earth. There's lots of other canyons on planet Earth. Some of them are even bigger than Grand Canyon, but Grand Canyon, because of its immense size, maybe because of its color, the variety of colors, and the high elevation and the width, and it's just made to be viewed. It's the best known example of hydraulic erosion on planet Earth. Of course, back a little over 100 years ago, was made a national park. And as a national park, it has about 4 to 5 million people that come every year to see it. And so it's ranked among the 7 natural wonders of the world. I think it's ranked number 1, is it? In the 7 natural wonders of the world. So it's the best known example of hydraulic erosion on planet Earth. It's hard to find a second, but just so much has been said and appreciated by hydraulic erosion on Grand Canyon, at Grand Canyon. 4 to 5 million people a year go to see it, and that's, of course, one of the questions that we ask as we see the Grand Canyon is, how did that hydraulic erosion occur? The second superlative, it's the most carefully scrutinized by geologists of all canyons on planet Earth. It's the most carefully scrutinized by geologists of all canyons on planet Earth. And you can easily prove that by going to the geologic publications on erosion of Grand Canyon. All of the erosion papers over a period of 160 years, geologists have been talking about this issue. And it's been an unsettled question largely. And so geologists have spent a lot of time scrutinizing canyons. And of course, Grand Canyon is the most carefully scrutinized of all canyons on planet Earth. Now, the third superlative is kind of a therefore superlative because of these first two. And here it is. Grand Canyon is the most important landscape on planet Earth to be explained by competing creationist and evolutionist paradigms. Because it's the best known example of hydraulic erosion on planet Earth, and it's the most carefully scrutinized by geologists of all canyons on planet Earth. Therefore, it's the most important landscape on planet Earth to be explained by competing creationist and evolutionist paradigms. And we should listen as the competing paradigms give different points of view and interpretations of Grand Canyon. There's the International Space Station oblique image from over Arizona, looking to the northwest along the axis of the Kaibab upwarp. Now, if I point, I can point to it here. Here you see the plateau. See the uplifted plateau? That's called the Kaibab upwarp. And it has a forest, and it's about 70 miles long. The width of view is about 100 miles wide. So this is an International Space Station shot from very high up, and you're looking at eastern Grand Canyon. The canyon is positioned through an upwarp plateau. The highland area where the canyon appears is higher than the lower areas to the upstream, off to the northeast and down to the west. It's lower terrain. And so Grand Canyon is a canyon eroded through a mountain range. Okay, that is a really interesting point for discussion. And that's one of the most critical questions that geologists need to answer. Anyway, you see the upwarped area and the canyon. The canyon is 4 to 18 miles wide. It's a mile deep, and the whole length of Grand Canyon is 257 miles long, counting Marble Canyon upstream, this area up here, to the northeast of Grand Canyon. And you're just seeing the eastern half of Grand Canyon in this image from high in orbit from the International Space Station. So you can see the Kaibab upwarp, and it is an upwarp, and the canyon is positioned through the upwarp. And in the bottom of the canyon is the Colorado River. And then you see Marble Canyon upstream, 50 miles or so upstream, all the way up to Lee's Ferry. And you see the Paria Plateau, the Echo Cliffs Monocline, Kaibabito Plateau, and of course, then you see the entry of the Little Colorado River. That's another basin that's upstream from Grand Canyon. That basin is an enormous catchment area and part of the discussion of erosion of Grand Canyon. And then downstream from the upwarp area you can see Kanab Creek and the Kanab Creek Canyon, and southern Utah up there on the north side, and you can see Havasu Creek and Havasu Canyon. Those are tributary canyons that go into the Colorado River main channel of the Grand Canyon below this long stretch, upper stretch of the canyon. So Grand Canyon is the canyon that's positioned through an upward plateau. There are four commonly held theories or hypotheses to explain the erosion of Grand Canyon. And I'll give them to you in historic order. These are in historic order because I'm remembering the erosion of Grand Canyon. I'm going to give it to you in historical order. Spillover was the first hypothesis for the origin of Grand Canyon, the earliest hypothesis. And the spillover model supposes the uneven terrain of northern Arizona up into Utah, all of that uneven terrain pre-existed before the Colorado River arrived and cut the plateau to create the canyon system. Hydraulic erosion obviously eroded the canyon, and the idea of the first hypothesis here is spillover. There are high areas and low areas, and the high areas are divides between low areas, and the low areas become filled with water, and they are lakes. And those lakes fill the basins, and those basins fill, and then they spill over the highland terrain. And as the spilling occurs, the flow notches the highlands and cuts a canyon through the highland areas. And there are probably multiple spillover events, but these lakes on the plateau were thought to be connected by spillover and then erosion of the Colorado River canyon by spillover. So the latest entry to the terrain in the spillover model is the Colorado River. It's a young river. It's an old topographic surface. That's what the spillover hypothesis proposes. Spillover. It's elegant and simple. People understand it, and but that's the spillover model. It was proposed in 1867 or 1857. Antecedency, 12 years later, was proposed for the Grand Canyon and Colorado Plateau. The antecedency idea of William Morris Davis and John Wesley Powell. John Wesley Powell is the early explorer of Grand Canyon. John Wesley Powell proposed the antecedency hypothesis. His hypothesis was the Colorado River is very old and that the canyon appeared by the terrain being warped and the low surface being elevated as the river system continued to cut downward through the plateau as it was uplifted. In other words, the river is immensely old. Some of the antecedent river proponents say back in the time of the dinosaurs in the Cretaceous period, there was a river flowing over a flat, low elevation surface next to the ocean. And then what happened? The terrain was elevated and arched, and the Kaibab upwarp formed as the Colorado River cut down. The old river and the young and the old canyon formed as the uplift process occurred. Antecedency, that's the John Wesley Powell on his river expedition. He saw that. It's not what you can see in Grand Canyon, it's what you can imagine. And John Wesley Powell had an eager imagination for the antecedent river, the old river, the new uplift and erosion of the terrain. The third explanation or hypothesis is called stream piracy or piracy. And the idea is the plateau land in northern Arizona was isolated, not having a river. Instead of spilling over, there was an upper river system off to the east, and there was possibly a small gully off to the west. And the gully erosion occurred so energetically, this precocious gully eroded headward through the Kaibab upwarp and intercepted the upper drainage of the Colorado River Basin and diverted it through the Grand Canyon Gully. And that's the piracy idea. Stream piracy was elaborated by E.D. McKee, Edmund McKee, 1964. He elaborately stated it and it became popular. Stream piracy, or the precocious gully theory for the erosion of Grand Canyon. The Colorado River formed by capture of the upper drainage basin by a gully. The fourth hypothesis has appeared recently, just in the last few years. That's the flood drainage theory. And creationists have proposed that it was not spillover, antecedency, or piracy that formed Grand Canyon, but that simply retreating floodwaters, as the floodwaters retreated, they became channelized and a current was formed, and that current focused its course over the uplifted terrain of the Kaibab upwarp, and the retreating channelized flow created Grand Canyon in a submerged ocean. In other words, it's a submarine canyon. The popular hypothesis, the flood drainage hypothesis, was proposed by Mike Ord. Mike Ord in his book, 1916 book, A Grand Origin of Grand Canyon. And Tim Clary also is an advocate of the flood drainage theory, all other creationists. And so those are the four theories or hypotheses for the origin of Grand Canyon. And geologists continue to talk about them and are generally aware of the various ideas that people are proposing. The big question is, are spilling lakes all it takes? Are spilling lakes all it takes? It's a great question to ask, isn't it? And the three of us who have co-authored this paper, myself, Ed Holroyd, and Dave McQueen, we are of the opinion that spilling lakes is all it takes, and that Grand Canyon forms nicely by this mechanism that we can talk about. Good question to ask, isn't it? Are spilling lakes all it takes? Okay, let me talk about two locations in Grand Canyon. First is Grand Canyon Village on the south rim of Grand Canyon. 4 to 5 million people go to Grand Canyon every year. Most of them go to Grand Canyon Village and see the vista of Grand Canyon from that location, Grand Canyon Village. There's another location that's not known to anyone. Hardly anyone knows about it. It's called No Name Point. If you talk to rangers at Grand Canyon about No Name Point, they can tell you, they'll know where it is, okay? And it has a name. among rangers at Grand Canyon. But nobody puts No Name Point on a map, okay? Because No Name Point is just that. The only thing that has going for it is it has a railing at the rim, and the Park Services put the railing there at the rim at No Name Point. But No Name Point is of special interest to me. Why? Because at No Name Point on Sunday, April 10, 1988, I gave a lecture on the rim of Grand Canyon. The lecture was called Erosion of Grand Canyon, where I talked about the breach dam hypothesis for the origin of Grand Canyon. In other words, spillover. 140 people came. There were 3 Greyhound buses that came, and people from all over the country came out to worship service and a lecture on Grand Canyon that Sunday morning, April 10, 1988. 32 years ago. Now, if you look at the map of the Colorado River drainage basin, this map is especially good at showing it, you can see that the Colorado River is divided into upper basin and lower basin. And the upper basin and lower basin have sub-basins. For example, there's a basin north of the Uinta Mountains with the Green River. It crosses the Uintas, and then there's Green River that comes into the Colorado River. And there's Gunnison River out here in central western Colorado, and that's a basin. And San Juan River, also part of the upper basin. The upper basin is divided from the lower basin by Lee's Ferry. Lee's Ferry is the division point between the upper and lower Colorado River in the Bureau of Reclamation maps that are drawn. And so Lee's Ferry is an interesting choke point and a discussion point. And then, of course, downstream is Grand Canyon. And there you see Little Colorado River. Little Colorado River is also a basin. Okay, actually a big basin, huge basin, 200 miles long. Okay, and so it's a significant area. So the Colorado River drainage basin is in parts of 7 states and Mexico. It's an enormous area. And of course, it's part of the Colorado Plateau. And the Colorado Plateau, because of the uneven topography, has created these basins, the upper basin, lower basin, that kind of thing. And you see some of the water diversion projects for the water resources in the southwestern United States, because the water resources are very precious. There's Glen Canyon Dam and Lake Powell. There's Lee's Ferry. There's whole Grand Canyon. Here's Lake Mead along the lower Colorado River on the Nevada-Arizona border going down into the California-Arizona border. And of course, the delta of the Colorado River is in Mexico, below Yuma, Arizona, and it drains into the Gulf of California, part of the Pacific Ocean. So that's the enormous drainage basin of the Colorado Plateau. Parts of 7 states and Mexico, enormous basin. 250,000 square miles of the Colorado Plateau in the upper part of that upper 2/3 of the drainage basin. Ed Holroyd, my co-author on this paper, in 1986, working with the digital elevation model that was made available to him through the Bureau of Reclamation, he used a computer to plot the position of the lake that could form if Grand Canyon was blocked at the 5,000-foot elevation. canyon was blocked right across the Kaibab upwarp with a dam over 3,000 feet high. A lake could form at just a little less than 5,700 feet elevation. Look how big that lake would be. It extends into the Little Colorado River drainage basin. That's the Painted Desert area in northeastern Arizona. And then it goes into southern eastern Utah and up into Colorado. And so it is, and even into New Mexico. So it's an enormous lake. Something about the size of a Great Lake could be contained behind Grand Canyon if it was blocked at the 5,700 foot elevation. There's a long story about how the lake was modeled. Ed Holroyd modeled it in June of 1987. He presented it as a paper in a creation journal called Creation Research Society Quarterly. And geologists and creationists started thinking about spillover even well before that time, but this was important in the last 50 years. Anyway, a huge lake could form. And this lake map was posted on the bulletin board at the Institute for Creation Research for 2 years between 1987 and 1989. And for 2 years, it was a discussion point, the bulletin board. It's kind of like social media today. Anything you put on this big bulletin board was a point of discussion. And geologists started discussing the big lakes that could form on east of Grand Canyon if the Grand Canyon was blocked by a huge dam at the 5,700 foot elevation. So it's an enormous, it's Great Lake size. Lake could form. Now, I believe that that lake did not form exactly that way. There's been tilting of the plateaus and some other tectonics that have led to lakes a little bit of different configuration. And I'll talk about that a little bit more here. Here's the spillover hypothesis that I like. Ed Holroyd and Dave McQueen helped me do this. Ed especially helped on the northern lake. There's a Canyonlands area north of Lee's Ferry, north of the Echo Cliffs monocline, the Priya Plateau, dominantly in southern Utah. That lake, I believe, was the 5,800 foot elevation. Ed Holroyd was first to plot that and notice there's a natural drainage spillway to the southwest from over Lee's Ferry. It looks like a breach. Okay, but the main lake that I've been studying and doing most of my work with has been called Hopi Lake. Hopi Lake is this large area directly east of Grand Canyon, elevation 6,000 feet. So this lake, Hopi Lake, was higher elevation than Canyonlands Lake up there in Utah. Hopi Lake filled the Painted Desert area and extended northward into the Marble Canyon area. And that lake was at 6,000 feet elevation up against a lower Kaibab upwarp. And the Kaibab upwarp was 1,000 feet lower, even more, when the lake breached. And the lake breached at East Kaibab spillover number 1, according to the hypothesis that I, Holroyd, and McQueen like. We like this spill to occur through the Kaibab upwarp and drain around through the terrain. It was diverted, I believe, by ridges of resistant strata. And so the Colorado River in Grand Canyon does this sweeping turn to the right. And it comes down to Kanab Creek area. and it apparently filled in this ponding area to the north side of the Kaibab Plateau, close to Telegraph Flat. And this ponding area later breached as water was filling from the breach from Hopi Lake. That Kanab Plateau Pond breached probably at Kanab Creek, and then it breached into the Havasu Creek drainage, which is a syncline, a downwarp structure, a natural basin that it found, and then that filled with water, and it overtopped directly below. And so there's a series of ponded drainage basins that were filled and then overtopped and then breached by the drainage. And so as East Kaibab spillover occurred and as the drainage occurred off to the west, the lake lowered in elevation to the elevation of Blue Moon Bench. Blue Moon Bench is less than about 5,700 feet elevation. Anyway, Blue Moon Bench, as it was exposed, there was a lake, a deeper lake to the north, and that new pond to the north spilled over at Nankoweap, spillover number 2. And then because a Blue Moon Bench separated into Hopi Lake into 2 lakes, the main part of Hopi Lake started draining through Cape Solitude area and Little Colorado River breach point. And that made 2 breach points and 2 spill locations. And so that's why we have Marble Canyon drainage upstream and the Little Colorado River upstream, and they intersect right there in the eastern Grand Canyon. So I think that Hopi Lake drainage was the primary mechanism for breaching the Kaibab upwarp. And as the Kaibab upwarp was breached and these lakes drained and multiple spillover points occurred, it made unstable the drainage area up to the north. And that's when Canyonlands Lake, at lower elevation, 5,800 feet, likely spilled through Lee's Ferry, that area at Echo Cliffs Monocline, where the Paria Plateau was breached. Let's talk about a brief history of spillover. Grand Canyon spillover was proposed by John Strong Newberry in 1857. John Strong Newberry was a geologist who grew up in Connecticut. His dad was a coal miner, had coal property in Case Western Reserve near Cleveland, Ohio, and Newberry grew up learning and observing coal fossils and coal strata. And so he was very well prepared to look at the strata in Grand Canyon. John Newberry was the first geologist to visit Grand Canyon. And in 1857, he was part of the Eves expedition that was part of an Army exploration expedition to explore the Southwest United States to find a railway access for travel from the Mississippi River to the Pacific Ocean. And so John Newberry and the Eves expedition together explored the Colorado River drainage basin. John Newberry came upstream, and in the central Grand Canyon area, he walked down Diamond Creek, and for 5 days, he observed the Colorado River at the entry of Diamond Creek in Grand Canyon. He saw the strata, and he recognized Grand Canyon was not an open crack or a cleavage area, that it was an eroded canyon. And so he recognized hydraulic erosion formed the canyon of the Colorado River. Now, what kind of erosion did John Newberry imagine? He wrote about it in his report extensively, and he proposed spillover. He went south along the south rim of Grand Canyon. He did not go into the Kaibab upwarp. He walked around the Kaibab upwarp in the eastern Grand Canyon, and he walked into the basin in the Painted Desert, the lowland area. And as John Newberry observed that terrain, he recognized that that was the area where water had ponded. And he recognized the mud deposits, which were later called the Bitahoche Formation in northeastern Arizona. And he proposed that a lake formed in that basin and that it spilled over the high country in northern Arizona to create the Grand Canyon. It was an immense work of genius that John Newberry conducted. He was the first to propose a theory for the erosion of Grand Canyon, and he worked out a good spillover theory for the origin of the Colorado River and Grand Canyon. That's John Newberry. Now, after Newberry came John Wesley Powell 12 years later, and of course, Newberry proposed spillover, but John Wesley Powell's expedition got more notoriety 12 years later. And of course, John Wesley Powell was the antecedency idea, the old river. But John Newberry recognized there's a young river across the structure that formed the Grand Canyon. Elliot Blackwelder, the chairman of the Department of Geology at Stanford University, was involved with studying the Colorado River near the area which is now called Lake Mead along the Nevada-Arizona border and also down California-Arizona border. And he identified lake sedimentary layers under river gravel in the Lake Mead area. He was surveying for Hoover Dam and the formation of Lake Mead behind it. And that geologic survey allowed Elliot Blackwelder to appreciate the young river gravel directly overlaying lake sediment, limestone, and other layers. He was well equipped to make the identification. And Elliot Blackwelder went on to propose much more than John Newberry. Elliot recognized that Newberry had the essence of the idea of how Grand Canyon could form. And Elliot Blackwelder proposed in 1934 that the whole drainage basin of the Colorado River from top to bottom formed by progressive spillover. And that's the spillover theory of Elliot Blackwelder. Elliot Blackwelder had a student. His name is Elmer Ellsworth. And Elmer Ellsworth was 23 years old when he enrolled at Stanford University. He needed a PhD dissertation. And Elliot Blackwelder said, hey, why don't you look at the Mojave Desert area and look at a place called Lake Mannix, the ancient Ice Age Lake Mannix, and see what you think. And as Elmer Ellsworth studied the lake sediment, he proposed that Lake Mannix drained through Afton Canyon by spillover and eroded a miniature Grand Canyon, 1/10 the scale of the big Grand Canyon. And Elmer Ellsworth wrote about it in his PhD dissertation 1932. And then, of course, he also co-authored a paper with Elmer and Elliot in the American Journal of Science, a well-known paper, a well-published paper, peer-reviewed paper. And at the time, that's when Hopi Lake was identified by Howell Williams. Howell Williams recognized the Bitahoche Formation, the mud deposits northeast of the Grand Canyon, and he proposed that Hopi Lake was a huge lake, about 12,000 square miles in area. And he identified and defined the evidence of that lake. He called it Hopi Lake, also known as Bitahoche Lake or Lake Bitahoche, because of the Bitahoche Formation, which is the geologic evidence for the existence of that lake. Creationists affirmed spillover in the 1960s. Henry Morris, Clifford Burdick, and Bernard Northrup in the 1960s were talking about the flood theory for the formation of the strata of Grand Canyon, and they proposed that the canyon formed in the post-flood period by ponding of water and by spillover. Morris was impressed by the theory and work of Byron Nelson, book Deluge Story in Stone, Post-Flood Drainage Created Grand Canyon. Burdick was impressed by Harold W. Clark work on post-flood drainage. Burdick rephrased his, and Burdick's model was rephrased by Morris, Henry Morris, the father of modern creationism. And then Northrup also had a post-flood drainage model. And these were, that was the creation consensus in the 1960s. The 1960s was a dark time for spillover. Why? Because the spillover theory of Elliot Blackwelder and Elmer Ellsworth were forgotten. Okay, for 50 years, totally forgotten, just ignored. And people didn't talk about those explanations, but creationists did. And Morris, Burdick, and Northrup reaffirmed the spillover ideas in the darkest time for spillover theory. So creationists were champions of spillover theory in the 1960s. And of course, I met those geologists and they impacted me with their spillover model. Mount St. Helens created a little Grand Canyon on March 19, 1982. A volcano erupted, a mud flow sculpted a 23 square mile area of landslide debris. Mud spilled over, formed ponding lakes, overtopped the terrain, and created a spillway to make a new Grand Canyon, a little Grand Canyon at Mount St. Helens. It was nice to have one of those to encourage creationists to continue to think about spillover. There was a lunch discussion in Pittsburgh, Pennsylvania, at Duquesne University in August of 1986. At that meeting was myself, Steve Austin, Ed Holroyd, and Dave McQueen. And that's the meeting where we described and defined a research plan for understanding spillover erosion of Grand Canyon. And of course, we went on to do research on this subject. That was the point where we started talking. The puzzle pieces were being assembled by 1988. Three things happened in 1988. Ed Holroyd had mapped plausible lakes. I had been working with plateau tilting and possible spillover locations. That was the first piece of the puzzle in 1980 that was being assembled. A second piece of the puzzle was a geologist in Tucson, Arizona named Bob Scarborough. Bob Scarborough was working with the Bittahoochy Formation, the mud deposits to the northeast of Grand Canyon, and he recognized there was no reason why Lake Bittahoochy could not extend westward to the Kaibab upwarp, and he started looking for evidences of the lake sediment off to the western side of Hopi Lake. And simultaneously, also in 1988, the third piece of the puzzle was being assembled. A geologist named Norman Meek was doing his PhD dissertation at University of California at Los Angeles. And he was doing his PhD dissertation on Lake Mannix, the Ice Age lake in the Mojave Desert. And he discovered something that Elmer Ellsworth, 50 years before, had elaborated an elaborate spillover theory with his professor, Elliot Blackwelder. And Norman Meek rediscovered the ignored views of these early geologists, and they pointed to the little Grand Canyon of the Mojave Desert at Afton Canyon, a 1/10 scale Grand Canyon. And then the spillover theory was nudged to the forefront in 2000. In the year 2000, a symposium of geologists on the south rim of Grand Canyon in June of 2000 assembled, and they went over the previous century speculation about Grand Canyon, and most of them were unsatisfied with that earlier idea. What was that early idea? The Grand Canyon was cut by the Colorado River over tens of millions of years. We all know what the Rangers thought in the 20th century. I learned about it in high school. That theory was debunked generally, and geologists were looking for something different. And the spillover possibility, the hypothesis, was nudged to the forefront. And there were a couple papers at that meeting describing the spillover explanation. And then spillover, how about this? Overflows to the popular press in 2008 to 2012. During that period, during that 8 to 10 years after spillover nudged to the front, that's when geologists and earth scientists started talking generally about spillover, and the popular press picked up on that explanation, which hadn't been heard of much, and so it got a lot of publicity and reports. Spillover overflowed. There was a geologist named John Douglas who produced a National Geographic documentary on spillover erosion of Grand Canyon. He also created a History Channel documentary on spillover at Grand Canyon, and new papers were coming out, and of course the popular press picked up on it, or press releases. And then Lake Mannix and Hopi Lake was challenged. From the period of about 2003 to 2013, during that 10-year period, spillover was being challenged by alternate theories. And champions of alternate theories were first in 2003 proposing that Lake Mannix in the Mojave Desert didn't form by spillover, that it formed by slowly. And Hopi Lake was challenged in 2013 by a gravel deposit at Crooked Ridge. The Crooked Ridge River gravel deposit was proposed to be a Miocene river that was plopped down into Hopi Lake Basin, a pre-existing low elevation river, which would seem to falsify Hopi Lake. And all of that challenge occurred. But then marvelously, there was a repentance among the authors of those challenging views, and new papers were published that seemed to argue that both Lake Mannix and Hopi Lake can hold water. And so between about 2014 and 2016, both Lake Mannix and Hopi Lake are being vindicated as real potential lakes for spillover. And of course, more creationists and evolutionists are recognizing spillover today. Today, there's about 20 PhDs, mostly PhDs in geology, who think sympathetically about Hopi Lake and are general advocates of spillover. And creationists are thinking about spillover today. So it's a good time to remember spillover theory. Here's the spillway at Mount St. Helens on the left, and there's a spillway from Grand Canyon. See the U-shaped canyon, see the meandering stream, see the amphitheater gully, amphitheater cup-shaped side canyons, gully-headed side canyons. There's a lot to it. We're looking directly down from the spillover points, looking down the path of spillover at the breach dam at Mount St. Helens and at the breach dam at Grand Canyon. There's a lot of similarity there. Is Grand Canyon a spillway formed from catastrophic erosion, like the Mount St. Helens spillway that formed in 1982 by catastrophic drainage on mud flow? Black Canyon and the Gunnison River was studied by Edmund Holroyd, and he proposed that the Gunnison River, which ought to have gone straight to the west toward Montrose, Colorado, his home, where he lived for 5 years. Ed Holroyd had all the opportunity to study this, and he proposed that was a spillover point where arch strata cracked and the drainage of the Gunnison River upstream from Grand Canyon was diverted through Black Canyon of the Gunnison River, through the crystalline elevated terrain. And it's a miniature Grand Canyon sitting there. It's a similar problem cutting through a mountain range. And then, of course, in the year 2000, in June of 2000, was the meeting of geologists. And the meeting of geologists didn't come to a synthesis on what eroded Grand Canyon, but they agreed Grand Canyon eroded it in a fraction of a million years. Geologists say that was a press release of the newspaper headline. And Wayne Rainey, in his book, Carving Grand Canyon, says spillover theory was nudged to the forefront as a result of the June 2000 meeting. And of course, then it became popular within 10 years. And so geologists were thinking about these issues. At that meeting is where some of the spillover papers were presented. And spillover was getting mentioned. And of course, we have the drainage basin map. Upstream, over in eastern California, see Afton Canyon, where I'm circling, pointing there. Afton Canyon in the Mojave Desert of California is a canyon that formed by catastrophic drainage of Lake Mannix, according to Elmer Ellsworth and Elliot Blackwelder in the 1930s. That Afton Canyon is shown here. Afton Canyon is a red eroded canyon about 4 miles long. Then there's an upper canyon system near Barstow, California. Here's Lake Mannix. And Ed Holroyd, my co-author, used his elevation terrain data, and he plotted Lake Mannix, about 90 square mile area, about 2/3 of a cubic mile of water at 543 meters above sea level. It spilled across the terrain and eroded Afton Canyon. And you see the outwash deposits downstream, and here's near Baker, California. So between Barstow and Baker, California is ancient Lake Mannix, which has been proposed to have failed by catastrophic drainage, first by Elmer Ellsworth and now recently by Norman Meek. the geologist from University of California, Los Angeles. Afton Canyon spillway looking upstream from the drainage basin, from the spillway. It's eroded 440 feet deep through even crystal and rock. And you see the drainage basin of Lake Mannix upstream, about 90 square mile area of lake up there. And then here's the basin upstream, which has been eroded, now channeled over a couple hundred feet deep. And you see the terrain that's been eroded. Norman Meek calls this badland topography. He calls it Canyonland topography. And of course, he thinks it resembles Canyonlands in the southern Utah, upstream from Grand Canyon. You can see the detail of the Canyonland topography. There's quite a bit of terrain that is marvelous. There you see the drainage area just upstream from the breach dam. In the bed of the lake, conglomerates have been eroded hundreds of feet deep. You see the organ pipe topography that looks like Bryce Canyon, of all things. So rapidly eroded landscape. The Bitahoche Formation is off in northeastern Arizona. Here it is at Roberts Mesa near Indian Wells, Arizona. And it's 200 feet of greenish colored lake deposits. And it has in it fish fossils, freshwater fish, amphibians. It has freshwater snails. It has a whole ecosystem of freshwater fossils. And that Bitahoche Formation is a site of 300 explosion craters called MAR, M-A-A-R. Coliseum MAR is one of the best known. It's about half a mile in diameter. Magma came up on the floor, below the floor of the lake. As it breached the lake floor and exploded, the collapse of the explosion created a downwarped coliseum, it looks like. And the back surge buried the fish of the lake in there. And of course, there's scoria cones around here, and there's tuff rings all around the big explosion craters. 300 explosion craters in the Hopi Buttes area, and lots of scoria cones with local scoria. It looks like no flowing water. It looks like a static lake environment, not a flowing flood deposit, if you will. And so that argues for the lake bed, not for a retreat of the flood simultaneous with erosion of Grand Canyon by a Grand Canyon ocean flood. And here's the pike minnow, the freshwater fish that today exist in the Colorado River drainage, and of course in the deposits of Hopi Lake. They were buried there at the explosion MAR in a mass kill. And so these are freshwater fish that are fast flowing. You know, they're good lake fish, not just pond fish. And so Hopi Lake was challenged, and the spillover model was questioned by Crooked Ridge River gravel, the Miocene Crooked Ridge River. Lucida, Ivo Lucida, Carl Karlstrom, and William Dickinson between about 2011 and 2013 published on Crooked Ridge gravel, and they said it was evidence of a Miocene river, a river and a canyon that pre-existed Hopi Lake and was flowing through an earlier Grand Canyon. Therefore, Grand Canyon could not be eroded by spillover of lakes. Was 2013 the death knell for spillover hypothesis? It would appear so. But what happened is a bunch of geologists started looking critically at the Crooked Ridge gravel, and proposed that it was not a Miocene crooked ridge gravel, it was a Pliocene crooked ridge gravel. And no, so Hopi Lake still holds water. How do you like that? 2016 was the year of repentance. Hereford's paper written in 2013 debunked the Miocene River, and they proposed that it was a Pleistocene river. And it was not a large river, it was a bunch of series of small stream channels, not a big river, and there was not a big canyon system in the Miocene time in pre-existing the Hopi Lake. And so this Hopi Lake still holds water. It's an amazing thing to see. So in the last few minutes, we've explained the spillover model for the history of erosion of Grand Canyon. We've taken a look at a couple of the other models, antecedency, stream piracy, and flood drainage. But the three of us, the co-authors of this paper, we believe that spillover is the best explanation for the origin of Grand Canyon. Is time the magic wand? No, time is not the magic wand. Time is used like a magic wand by many people. They suppose that this ancient canyon was eroded by the Colorado River over tens of millions of years. But time is not a magic wand. It's a recent river that recently arrived. Therefore, time is not the magic wand. It's the villain of the plot. And so we need to jettison this idea. And here we are 160 years after geologists first proposed the origin of Grand Canyon. We're asking, could it be that the geologists are laboring with ideas of millions of years which confuse rather than illuminate the correct understanding for the erosion of Grand Canyon? That's an amazing statement to be comprehending after 160 years of geologists looking at Grand Canyon. And so we talked about the brief history of spillover, and that history shows we have a good theory for the erosion of Grand Canyon.